Unit 4, Section 7. We're going to multiply a monomial by a polynomial. Now remember, when we deal with multiplying like bases, we're going to have to change the exponent by adding. Okay, that was one of the first lessons in this unit. So here are the steps. The first thing you're going to do is distribute. Okay? You're going to multiply the coefficients. The coefficients is the number in front. It's a fancy name for the number in front. Okay? And then don't forget we have to add exponents. So they're the three keys when we're multiplying a monomial by a polynomial. Okay? I'm going to actually show you a couple different ways to do this. Some of you will be okay with just distributing, and some of you are a little more visual, and so I'm going to show you the box method. And the box method will continue all the way out into Algebra 2 into doing some stuff. But let's just start with a plain old distribute. So 3x squared times 7x squared minus x plus 4. Now, you are going to get to the point, hopefully, that you can shortcut this, but I am going to show you every single step and every single step that goes on in my mind as I do this. So let's just do that with the first one. So we do 3x squared times 7x squared. Okay? Then we're going to do 3x squared. We're just going to add these together. I'll put that in a minute. Times negative x. I put that in parentheses because it looks like subtraction if you don't. Okay? And then I'm going to go 3x squared times 4. Now, in between all of these is just a plus for now. Okay? We'll see if we need to change that once we do the multiplying. Now, again, I'm writing out every single thought process as I go. So then what I'm doing is I'm going to do 3 times 7 and x squared times x squared. So I'm regrouping. I'm using the associative property of multiplication, which says you can regroup without changing the value. I'm going to go 3 and then x squared times negative x. And then I'm going to go 3 times 4 times x squared. Now this should look similar to the first section of this unit. So 3 times 7 is 21. We have x squared times x squared. Same bases. When we multiply like bases, we add the exponent. So this should be x to the 4th. Now this 3 here doesn't have anything to multiply by, so we're just going to leave that. And this is where you're going to have to be careful. Oh, you know what I should have done? Watch this. I really should have done this. Let me erase this middle term and show you what I should have done. This is really a negative 1, right? So when I rewrite it, it would be 3 times negative 1, x squared times x. That makes a little more sense to me. So 3 times negative 1 is negative 3. And then x squared times x, remember that x has an invisible 1 exponent, is really x to the 3rd. And then the last one is 3 times 4, which is 12. And then the x squared had nothing to multiply with, so we just leave it. We check to see if there's any stacking or adding that needs to be done. And in this case, we don't, because they all have different exponents. Now, there is one other thing you could do here. You could leave it like this, or you could simplify it further. Instead of plus minus, or plus and negative, you could put minus 3x to the 3rd. Either one is correct. But this is all the thinking. The hope is that you can go from the blue step up here right to here. Okay? That all of this eventually is done in your brain. Okay? But you're going to have to decide how much can you hold in your brain at one time and how much do you need to write down. And the more you practice it, the less you'll need to write. But maybe in the beginning you need to write each step. If you're getting them wrong, and I'm seeing you're getting them wrong, I'm going to start requiring you to write each step. Now, that's if you're distributing. You could also use the box method. I have found over the years that a lot of kids who are more visual thinkers, who are sometimes more creative in their thinking, like this method. And those of us who are more structural find this method just, why would anybody use it? So again, this just illustrates how we all think differently. So let's do this problem. 5a squared times negative 4a squared plus 2a plus 7. And we're going to continue using this box method, so here's what I want you to realize. We're doing a monomial times a trinomial, so we need a 1 by 3 box. It kind of is reminiscent of the lattice method, a little simpler than the lattice method. For those of you who hated the lattice method, I get that. I had a son who loved it. So again, different brains, different ways. And then we're going to write on the outside. On this outside, we're going to put our monomial. On the top, we're going to put our trinomial. This is really the area model. We're going to just multiply the lengths and the widths together. So 5 times negative 4 is negative 20. A squared times a squared. So they have like bases. This is a to the 4th. 5 times 2, so now we're doing the monomial times the second box. So 5 times 2 is 10. Now maybe you need to put a 1 on this to remind yourself that a has 1 as an exponent. A squared times a to the 1st is a to the 3rd. We add exponents. 7 times 5 is 35. Now don't forget, there is an a square on that 5, so that needs to go in that box also. So our final answer here is negative 20, a to the 4th. Now remember, this really has a plus in front of it, and so does this. So plus 10a to the 3rd plus 35a squared. So that's the box or the array model or the area model, okay? So the third one I want you to choose. I'm going to write the problem. I want you to pause the video. I want you to get the answer and then check it with mine. And see if you get it wrong. Remember, failure helps you learn stuff. If you get it wrong and you can figure out your mistake, you've learned a lot. You've made a lot of brain connections. If you get it right the first time, you understand it. You're good to go. If you try and you get it wrong and you can't figure out what you're doing wrong, that's when it's time to talk to me or Miss Sally or any of the other teachers that you work with, okay? And we'll help you get there. You'll get this. All right, so pause the video. Try this. All right, so hopefully you have an answer that you didn't just keep going, but I can't stop you if you did. So I'm going to do 6 times 3 is 18. D to the 3rd times d to the 4th. We add exponents. D to the 7th. Did you get that first term correct? If not, can you figure out what you did? Did you actually accidentally put 9d? That means you added 6 and 3. Common mistake, but you got to keep practicing so you don't do that. Did you put d to the 12th? Well, that means you multiplied your exponents. You're supposed to add them. So start thinking about if you made a mistake, what mistake did you make so you don't continue to repeat it. All right, the next one. We have 6 times negative 2. That's going to be negative 12. We have d to the 3rd times d to the 3rd. Adding exponents makes that d to the 6th. And then the last one, 6 times 9. If you're like me, the 9 times 6 and 9 times 7, those are always a little fuzzy in my head. So 9 times 6 is 54. Did you just multiply wrong? That's common. So 9 times 6 is 54. And then we just have a d to the 3rd that got multiplied by nothing. There was nothing there to multiply it by. So this is our final answer. Were you able to get that answer? Okay, so you know what you need to do if you didn't get the answer and you can't figure out your mistakes. Otherwise, you can move on to your homework and see what you can do.